Hello everyone. So in this video we're going to talk about break-even analysis as one of the tools to evaluate the alternatives. So from a capacity planning viewpoint, when a company needs to make a decision if they're going to expand the capacity in order to serve the future demands, so one of the things you want to look into is the economic feasibility of the capacity expansion. So you want to answer some of the questions like, will an alternative be economically feasible? So when I say alternative, do you want to build new capacity by doing some capital investment, which we'll regard as fixed cost when it comes to break-even analysis, or shall we outsource? Maybe it's not sensible to commit huge amount of funding in order to build the facilities, to buy new equipment. In some cases, it's more sensible, instead of building our own capacity, to outsource the job to the other companies who are better doing the job, right? So as I mentioned in one of the classes, there are a number of tools, such as you can look into net present value, payback period, return on investment, and break-even analysis. So in this course, we will look into the break-even analysis. Okay, so the break-even analysis analyzes the relationship between cost, revenue, and volume. Okay, so let's break these down. So when it comes to costs, we are going to break it down into two key categories: fixed cost and the total variable cost. So fixed costs are the ones which remains constant despite of the quantity of output. So some of the examples you can think of fixed costs are like property tax, machine cost, facilities cost, right? So costs in terms of leasing or building, buying land. So that will be independent of the number of units being produced, right? Similarly, other expenses such as related to maintaining and running operations, such as heating and cooling, administrative cost, such as supervisor salary. So all those are the examples of fixed costs which are independent of number of units being produced. So on the other hand, the total variable cost will vary based upon the number of units being manufactured, right? So costs related to materials, costs related to defects, costs related to hourly staff wages, right? So all those are the examples of variable costs. So as you manufacture more units, your variable cost will increase because it's function of quantity, right? Okay, so by knowing fixed costs and the variable cost, we can get the total cost, which is fixed cost plus variable cost. Similarly, by using the number of units, we can get the total revenue. So the total revenue will be function of quantity that's being sold multiplied by the price per unit, right? So that's what we have here: quantity, price per unit, and the total revenue, right? So for profit, the simple formula is total revenue minus total cost, right? At break-even point, what we have, the profit equals to 0. So when you're calculating the break-even point, you're going to insert profit as 0 when it comes to numericals. So as we said, at break-even point, the profit is 0. So which means you're not making any loss, you're not making any profit, you're breaking even, right? So from here, from the above explanation, you're only going to make profit when the demand is larger than the break-even point. On the other hand, if the demand is smaller than break-even point, you will not make profit, so there will be a loss. Okay, so if you look at the formula for the total cost, as we said in the previous slide, so the total cost is function of fixed cost and variable cost, right? And the variable cost is function of quantity and the cost per unit. So on this plot, if you have quantity along x-axis and the dollar value along y-axis, so your fixed cost is going to be a constant line along x-axis because this is not influenced by the quantity, and the variable cost is going to be a straight line. So one of the assumptions that we're going to use in break-even calculations, that the cost per unit remains same regardless of the quantity of the output. So which means we are not considering anything related to defects, reworks, or the quantity discounts, right? So we're going to use a straight line here. Okay, so the next comes is the total revenue. Pretty straightforward. So again, along x-axis we have quantities. This is along y-axis is the dollar value of the total revenue. So when there's no quantity, your revenue is going to zero. As we increase the quantities, so it increases on a linear scale. So again, keep in mind that we are not considering any quantity discounts, reworks, returns, and so on. So the revenue per unit remains same regardless of quantity of the output, right? So from here we can calculate profit. So profit is the difference between total revenue minus total cost. So I will not walk through this because we are simply inserting these values from the total revenue and total cost. So once you solve this, you're going to get the quantity Q equals to profit plus fixed costs divided by revenue per unit minus variable cost per unit. So from here, as you insert profit equals to 0, so this formula is going to give you the break-even point. Okay, so from here, let's apply this formula. The next video will go through question number 6 in your worksheet, and I will see you in next video. Thank you.